Good morning to everyone present over here, and I'm Banupriya, working as an assistant professor in KSR College of Engineering, Tirchangur, and I'm here to discuss about some important concepts of stack data structures. Uh, so stack is an ordered, so it is a collection of some ordered list of elements in which we can insert and delete an element from the top. So a stack is nothing but some collection of elements arranged in some order, or the collection of cards arranged in some box, or a collection of biscuits arranged in some big biscuit packets, or anyone which is placed in some ordered collection inside some box means we can refer as a stack. It is some ordered collection of elements. Here elements may be inserted and deleted at only one end, called the top of the stack. So here it is following the last in first out and first in last out principle. So that is, the element which is inserted last will be the elements deleted at first. So the elements can be added and removed from the top of the stack. That is, the lastly entered item can be removed at first. Next, the basic operations of the stacks or push and pop. So if we are inserting some element into a stack, it is referred as push operation, and we are deleting an element from the stack is referred as pop operation. And if we are inserting some element into a stack, the arrow is coming into the stack, and if we are deleting means the arrow comes out of the stack. And the top represents the first element of the stack. So the based upon the top position, we can able to delete an element from the stack. That is, we can able to delete or insert only from the top of the stack. Next, the additional operations of the stack are the peak operation, and is full and is empty. So the peak will give the first data item. First data item of the stack, so that the peak will get the first data item. And is full, if we are inserting an element, we have to check is full condition. If it is already full means we can able to uh, 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 we can able to take an element, but if it is already full means we can't insert one more element into a stack, which will result in stack overflow. Next, if we want to delete an element, we have to check for is empty condition. Because we can't take an element from the stack if it is already empty, so which will result in stack underflow. And we can implement the stack in two ways, so static implementation and dynamic implementation. So in the static implementation, we are using some array. So as similar concepts used in array of 0, array of 1, 2, 3 and 4, we are inserting 10, 20, 30, 40 and 50. And if we are using dynamic implementation, we are using some linked list. First element stores the address of second element, and second element stores the address of third element. Likewise, it will move on up to the last element. And the stack pointer represents the top pointer. The top is the pointer which is pointing the first element of the stack. That is, the last entered element will be the first deleted element. So top is pointing the last inserted element. If for an empty stack, the top value is -1, and for if we are inserting some element, the top value gets incremented, and if we are deleted an element, the top value will get decremented. And if we are using some array implementation of stack means, we can use the same concepts which is used in array, that is int s of 5. Here S represents the array name, and array size represents the size of an array. Hash define array size 5, which is a macro. So likewise, what we are used to declare an array, here we are representing the same concepts as in array. Here, instead of some array name, I am representing for S, for clear understanding. That is, S represents the stack size. Next, so for a routine to check whether the stack is empty or not. If the stack is empty, can we able to delete an element? If it is already empty means, what is the top value of an empty stack? Top value is equal to -1. So if it is, the top is having some value which is equivalent to -1, it will the function will return 1. If it is returning 1 means the is empty condition is satisfied, which is saying something about the stack is already empty. And if we want to insert an element, we have to check whether it is already full or not. If it is already full means we we can able to can be able to insert into a stack. If it is already full, we can't. So if it is already full means if we need to insert an element, we need to check the array size is full or not. So for that, I'm using some statement if top is equal to array size minus 1. If the condition is satisfied, that is top is equal to array size minus 1, the function will return 1. If it is returning 1 means and the is full condition is satisfied. And if is full condition is satisfied of the stack, yes means we can't insert some more elements into a stack. If we need to insert an element into a stack which is already full means it will result in stack overflow. And so inserting a new data element into a stack, these are all the steps we are following while inserting an element into a stack. So the step 1 represents if a stack is already full means. So what we can do, we can't insert um, if it is not full or else something. So there is some space inside the stack means we can able to insert. So for each insertion, so let us consider this example. So some 5, 4, 3 are the elements which is needed to push into the stack. The elements are 5, 4, 3. If we need to insert means the first element is 5, then the top value is incremented by 1. Next we are putting the 4, the top value is incremented again 1. Next, for next insertion, that is 3, it is getting incremented by another one. So it is, so each and time it is incremented by 1 after each insertion. So top value is incremented by 1 for insertion and top value is decremented by 1 for each deletion. And for an empty stack, the top value is -1. So these are all the things we have to keep in mind while for insertion and deletion. So routine to push an element into a stack. If we need to push an element into a stack, here the stack S represents the name of the stack, and X is an element we need to push into a stack. So as I've already said, we need to push an element into a stack means what are the condition we need to check if the stack is already full or not. Whether the stack is already full or not, the answer of this question says we can able to insert or delete. So if it is full means can we able to insert? So no. So the function will giving some error message that the stack is already full, insertion is not possible, like that. So if it is there is some space, so we can able to can we able to insert some elements into a stack. If it is some space is there means we can able to insert. So for that insertion, the top value is incremented by 1. So now the incremented now the inserted value represents X, the top value is incremented by 1. That is, the top should point to the location which is the last entered element. That is, the last element inserted element pointer should points the top. Next, for deleting, so each and every time it is deleting, the top value is decremented by 1. So for deletion, it is checking some empty condition. If it is already empty means we can't able to delete an element into a stack, which will result in stack underflow. So it next comes the linked list representation of stack. So here are some four elements: 99, 50, 32, and 25. So 99 is a first element, next is 50, next is 32, and next is 25. So 99 at the node. So 99 is the data, and the nearby compartment represents the address of next data. So the 99, 50, 32, 25 are occupying some nodes. So for each and every node is having some data portion and some for a linked list. We are traveling, that is we are visiting first time the first node. So next, it is displaying the first element data. Next, visiting second element, it is displaying second element data. Next, third element, displaying third element data. So how long we can continue means, whenever the pointer is pointing the null position, which represents this is the last element of the stack. So up to traveling the last position, that is the last node, it is printing the data of the node. So that is a concept. And peak returns the top element. So peak represents the first element. And stack operations using linked list. So for implementing a stack using linked list, I'm using some node data structure. So node means, so we have to create some memory for the node, and data, and struct node for pointer. We are using struct node next. And if top is null means it is representing the empty node. So push value, so inserting an element into a stack. So for inserting an element into a stack, we have to create a new node. Next, we have to check whether the top is null. If it is null means we can able to insert. So the first inserted element, for the first inserted element, the top is pointing. So the first element next pointer points to null, because this is the first element. There is no more new nodes inside the stack. This is the first element we need to insert, means its next pointer points to null. If it is not empty means it's so new node next is pointing to top. Finally, we are setting the new node to top. The same principle applies also for deleting an element. So check stack is empty, and if it is empty, then display stack is empty and deletion is not possible. If it is not empty means, so there is some element inside the stack. So assigning that element to temp and set it as top. So top is equal to top next. So likewise it is um, so the top next pointer points to the current top. Then we are deleting the temp variable using, that is temp element using free of temp. So free function, it is used to delete the memory space which is allocated for that particular element. But now we are deleting, so I'm using the free function to delete that particular variable. And for display function, so if anything wants to display means there should be something there inside the list. So for displaying, we have to check whether the top is null or not. If it is null means the stack is empty, else I'm creating some pointer. So the temp is pointing the top. So if the temp next is not equal to null means, what is it is checking? There is some second node or not. So if there is some second node means the first node data is printed. Next, the temp pointer will get incremented. Again, the loop will continue up to the last element, it is checking whether it is some element or not. Up to the last node it is checking, and temp is getting the temp next is assigned to temp. Likewise it is iterating up to the last element and printing the temp data, that is the first node data, and next the second node data, third node data, fourth node data. So likewise it is displaying these elements of the stack. And the applications of stack represents, so for the main application is balancing the symbols. Then compiler is if we are writing a program, the compiler is checking whether the written program is right or not using the syntax parsing and parenthesis checking. So compiler is using the stack to verify whether the program written by you is right or not. And for backtracking, we are using the applications of stack for a string reversal and a function called reverse recursion. And towers of Hanoi is a puzzle program. And for that, so in the puzzle tower of Hanoi puzzle, there will be some two posts will be there, and inside and the first post is having three disks arranged in an increasing order from top to bottom. And we can use some intermediate disk. With the help of intermediate disk, I'm shifting so for shifting purpose I'm using some intermediate disk, and the order should be maintained in the first post as well as the third post. So first post, the disks are arranged in increasing order. The third post should be arranged in increasing order as similar as that of first, but we can use the middle one as an intermediary. So in that puzzle problem, we can also use the stack. And for arithmetic expression evaluation, arithmetic means a plus b, all the arithmetic operators. If an arithmetic operator it is involved in some expression, means it is arithmetic expression. And how we can evaluate the arithmetic expression? For that, we can use the stack. And for infix expression notation is nothing but what is the real order of some expression. Let us say some example, we are calculating a plus b or a minus b, a star b, a slash b. For any expression, if it is present in that order, that is in the actual order, we can call it as some infix notation. For prefix notation means for a plus b, the prefix is, so we are prefixing, that is for before the operands we are prefixing the operator, that is prefix expression. And for postfix, we are moving the operator to the backside of the operand, that is how we are shifting the operators means based on the precedence rule, that is brackets of division, of multiplication, addition, subtraction. Based on this calculations, we can so based on the precedence rules, we can moving the operators front and back. uh, so these can help for balancing the symbols using so this will help the compiler to move to check the program which is written by you. And so, as I have already said, the a plus b, for a plus b, the prefix notation is a plus ab, and the postfix annotation is ab plus. And the same only. And then the levels of precedences, exponentiation got first place, that is the highest precedence operator. Next comes multiplication. Next comes next high is multiplication and division, both are already equal. And the lowest comes addition and subtraction. And for conversion of infix to postfix expression, um, we are using the stack. So a minus b becomes a b minus for postfix, and d plus e represents d here. D plus e represents de plus, and a b minus. So the operator comes after the operand. That's the concept. And the conversion of infix to prefix. So a minus b is written as minus ab. D plus e plus de. So likewise it is And the conversion of infix to postfix using stack, we have to scan the expression from left to right. If the scanned symbol is an operand, we can directly output. But if it is an operator, we can use the operator stack. So please remember, we are using the operator stack for conversion of infix notation to postfix notation. So if a higher priority operator comes after the lower priority operator, it is acceptable. But lower priority operator comes after the higher priority operator in the stack, means we can push the last entered element, we can pop the last entered element out of the stack, and we can push into the output expression. It will be more clear when you are seeing the examples. So see, a so open A plus open B star C minus open D slash E tap F close star G close star F H close. So for this expression, this is the postfix expression evaluated using the operator stack. The stack here represents, this is the operator stack, and the postfix expression here represents the output expression. C A B C star D E F cap slash G star minus H star plus is the expression we are getting at the end. And see, these are all the symbols scanned. So the first symbol, second symbol. If the scanned symbol, so the scanning starts from left to right. So the scanned symbol is operator, means we can push into the stack. If it is an operand, means we can push into the postfix expression. So likewise, the order continues. So if, so see here. So star is having then minus. So star is having higher precedence than minus. So we are pushing the star to the output expression. So as I have already said, okay. So high comes after low. It is acceptable, but low should not come after high precedence operator. This is the basic concept. And some may done mistakes in the last, so in the last in the 20th step. So because whatever there is inside the stack should remain on the output expression, so we should empty the stack. That is a point we should remember. And this is some so using some numbers we are converting this infix to postfix. So this is the same operation only, similar as we have said already. So 3 is an operand and star is an operator, 3 operand slash open operator, 4 operand minus operator. So likewise, so the general concept is we should not, so the step 1 is we should push the operator into an operator stack. We can push the operand into an output. If the operators are coming nearby, means the lower priority operator should comes after higher priority operator, means it is not accepted. But higher priority operator comes after lower priority operator, means it is accepted. This is the basic rule. Okay, if you have any doubts, means you can clarify. And whatever we are discussed in this lecture is, so what is a stack? So what is a stack and how the stack look like? And a stack, how the stack becomes after insertion and deletion. And stack is following LIFO-FILO principle, and the operations of the stack, push and pop, and the functions of the stack, additional operations, and how we can implement the stack. What is the top pointer? And top pointer value, how will be updated after insertion and after deletion, and how we can declare the array elements of stack, and the routines to check whether the stack is full or not, and how we can push the element into a stack. So if we are pushing how the top variable becomes how it is incremented, and deleting, and then next like list implementation of stack operations in the linked list. We are creating node, and for inserting we are making a new node after delete. If we are deleting means we are freeing the node for memory deallocation. Next push pop. Next display function, that is visiting each and every node at least once and printing the data. And conversion of infix to postfix expression, balancing the symbols is the basic uh, application. And arithmetic expression evaluation, converting from infix to postfix, prefix, and the precedence with the help of some examples. Thank you.